Hey guys, so this is a new video. Like in last video, episode I think 6, we talked about perfect numbers. So this video we're talking about prime numbers. So I'm just gonna quickly open up my folder. Which one's it? Yep. So last time when we discussed about the 34 line. Not this again. So like last time when we discussed about the 34 line perfect number generator, we talked about different functions here, like the isPerfect function, which checks if it's perfect, then the perfect numbers one that stores perfect numbers, all of that, and the try except method that makes it more efficient to do these things. Okay, yep, my Mac is definitely working. Okay, so now we're doing the 54 line prime number generator. So I'm going to go through this really quickly, and we'll also get a quick preview. Just so you know, both my perfect number generator and my prime number generator are going to be on my Python images and logos repository in GitHub. So there's been a bit of an update. The Python images and logos, I couldn't figure out how to rename it, so I just decided to stick with it. And so now basically every single Python thing that I do is on that. So now get in. So, to not make this video way too long. So we need to make this eligible for Python 2, because I've coded this specifically so it's available for both Python 2 and Python 3. So it starts with an import from future. So the future, import the print function. Then import sys. Then defines generate primes limit. Just like perfect numbers, it's generate primes, which does basically both together. So it's going to do actually a bunch of try except here. So then what we can do is, there's a try. It's going to try and validate the input. So if not is instance, limit and int. So int. Then or. So if not is instance, this is not an or, limit is less than 2, raise a value error. Limit must be an integer greater than or equal to 2. So it must be an integer, as described here, and it has to be greater than 2, not less than 2. And then the initialization for the sieve array. Sieve equals true. What's that? Hold on. I need to check something. Yep. True. Multiplied. Limit plus 1. Okay, I don't need that. Sieve equals 0 equals sieve equals 1 equals false. So that puts a bunch of logic, which starts to get confusing when you go way too far into it. Then it implements the sieve into eris. Yeah, that word. It took me a long time to Google and find that. So I'm not going to try and do that again. So it's going to do all this. And then it's going to have an if statement, if c I for j in range I times I, limit plus 1, I see if j equals false. Then it generates the list of primes. Primes equals num for num in range 2, so it starts from 2, and then the limit plus 1. If sieve num. Num is the, so sieve is the other array sieve that we've created. And so what we're going to try and pick up here is how there's also, after that, if there's any exception of a memory error and it can't generate enough primes to that limit, it's going to print it can't, and it's going to return nothing or none described in Python. Then an exception as exception, an other exception doesn't know, it brings that in as E. Yeah, when I highlight that, there's a lot of E's in this entire script. Then it's going to print an unexpected error occurred. And then it's going to put in 0, format, string, E. And then it's going to return nothing again, as exceptions shouldn't really return anything. Then the main is where it's going to, if sys.versioninfo 0 is less than 3, limit equals int raw input and generate primes up to. So it's going to be a raw input. And it's going to be an integer too, because you convert that to an integer from a raw input from it. Yeah. So then else, limit equals int input generate primes up to. So that's going to be a normal input instead of that keyword. That, yeah. So this is actually just for if it's Python 3 or Python 2. If it's Python 3, I'm pretty sure, yeah, it does one of these for Python 3, one of these for Python 2. And that's an if-else statement, so only one of them runs. Then primes equals is generate primes limit. So it's going to use the generate primes function. If primes is not none, so if the primes is not none, so there's not any primes. If there's not any prime, okay, yeah. If there is primes in there, then it will print primes up to that format limit primes. So the dot format limit primes, what it's going to do is, so these are index numbers. I may have not told you what these mean, but these are like formats. So when it puts dot format limit primes, pretty sure this is how I coded it, but because I coded this like 2 weeks ago. So I put this, I'm pretty sure the index of here matches these numbers. So 0 index, this is 0, 1 index, this is 1. So primes, the amount of primes is going to show here, limit is going to show here. So much harder in Python 2 though. And then, so after that, it's going to have, after that try in def main, it's going to have an exception list, basically, which with the value error as VE, invalid input, 0, format string VE. So it's going to show you the error in there, right there, just like in the rest. Then another exception. If another exception comes, keyboard interrupt, meaning you could just randomly click a key and just do that, then it's going to say operation canceled by user. And then if there's another exception, it's going to say an unexpected error occurred, and it's going to show you that error. Then finally, so it's this list is always going to come. So this is always going to execute no matter what. It's going to say print. It's going to print program execution complete. Then this if name equals main thing is just to make sure that it's not running as the main branch when it's not the main file that's meant to be executed. So that's it. Now we can check this. We can run it. So I'm going to do at least here. What I'm going to do, I'm not going to do too much because one time I did 1,000,000. I couldn't even scroll through the list. It was that laggy. So what we're going to do, let's do 100. 100. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97, and then that's it. So that's all for today's video.